To the following trap monobehavior code, we are just calling the rigid body. Here we are calling it trap RB. You can rename it to RB if you want to call from the player movement too. And then making a poll for player entered and equal it to false. It is usually equal to false from the beginning or from the awake method, but you can specify it here too. In the start method, we are getting the rigid body of the trap, then making its gravity scale equal to 0 or disabling its gravity. Then in the update method, we are checking if the player is entering the trigger or not. Then if yes, making its gravity scale 3. You can also make a public float here, making it a variable for gravity scale number, and then put it here and replacing the 3. So you can increase the value by a slider. Then on the private void on trigger enter, we are seeing the tag player. So you need to tag your player with a similar tag and checking the syntax to be true. And if yes, the player entered is equal to true. This is not a loop, so this following trap only runs once. If you want a loop, you can make a quarantine that make the player enter false after a time. The spike code is very simple. It's just making an on collision enter 2D, which is different from the on trigger enter 2D. You can check it from the second episode of this course, checking the collision of the game object by comparing the tag player2 and then finding a game object of type player death manager and making isDead true. The death manager is very simple. We are checking if the player is dead or not from this variable isDead. On the awake method, making isDead false. You cannot call it from the start method because the awake method is before the start method, as we explained in episode 2. Then on the update method, we are calling isDead. If it's dead, then call the function die. The function die is just resetting the scene. This is not an industry standard. It's just a course because you need to make a room for the effects and for the sounds, so they will run in a quarantine for a death function, then resetting a scene, and you might not want to reset the scene if you have a death counter. So maybe make a checkpoint for the player initial position. For the patrolling platform script, it's simple. You just need to specify the move speed, the move distance, that you can also make a gizmos for if you want. And then the private variables are a vector3 of the start position and the direction. The direction will be an int. It's either 1 or -1, 1 being right and -1 being left. In the start method, we will check our start position and make it equal for the transform.position, which is the initial position of this object according to its world position. Then on the update method, we are taking the transform.position and make it equal to the vector3 right, or the x-axis or the right x-axis, and then multiplying it by a direction and a move speed. And all of this will be multiplied by the time.delta time. So this if statement is to reverse the direction of the platform. We are checking the vector distance start position, then the transform.position, and if it's larger or equal to the move distance, then the direction is multiplied by -1 to make it -1, so it moves to the left. Here we have a very simple on collision enter and on collision exit, which makes the player a child of it. So when the player will move, the player will be able to move freely and stay still on the platform itself. This is very important, and this could only work with such a player movement script, but because in some player movement script this could make some problems, especially by setting it's a child for a parent game object. So keep this in mind. The swapping platform is a bit complicated, but it's really easy. We have two headers, one for the platform settings and one for the sprite settings. The one for the platform settings have a disabled duration, enabled duration, and initial delay. The disabled duration is the time the collider is disabled. The enable is the time the collider is enabled, and this should be equal usually according to your gameplay design decision. And the initial delay is the time before the first swap starts. This is important if you want to make one is opened and one is closed. So the first one is have an initial delay of 1 and the second one have an initial delay of 0. This will make them swap in with an initial delay. The sprite settings is disabling the alpha. It need to be 0.5 or any value you want, because it needs to look like it's disabled. You can also change the sprite if you have a custom sprite. This code has nothing related to visuals. These are just functions for it to work. Also, we have the original alpha. Alpha is from the RGBA color, which is the opacity. The private collider, getting then the private collider 2D platform collider, and the sprite renderer, which is the sprite renderer to get the alpha of the color, and then making a poll for is disabled. In the void start method, we have now multiple things. We will get the component of the collider 2D and the sprite renderer. The sprite renderer checking then if it's null or not. If not null, then making the original alpha equal to the sprite renderer.color.alpha or .a. You cannot get the alpha from sprite renderer.a because it's inside the function color of the sprite renderer. So you need to call it this way. Then invoke to make a delay, a name of start swapping, and making the initial delay is the delay. Here is also explained in the episode 2. Invoke is used for delaying. Then void start swapping. The start swapping calls a quarantine, and this quarantine is a loop. While true, disable the platform and then wait the disabled duration and then enabling the platform. So it's a loop, and inside this loop we have two waitings, one for the disabled duration and one for the enabled duration. And then set sprite alpha. This is an important function. This checks that if the sprite renderer is null or not. If it's not null, the color equal to the sprite renderer.color, and the color alpha is equal to alpha, and then the sprite renderer.color equal to color. This is very important if you want to get the alpha through function. So yeah, these are all the codes. This is a very simple project. I hope you enjoyed the video. I hope you can recreate this easily, because this is the basic of every platforming game. In the next episode, I will teach you how to add visuals to make more complicated systems for this game. And as I said, this is an intermediate course, not a beginner course. If you are a beginner, you will get overwhelmed very easily, so don't get frustrated. If you are a beginner, go check another course and then come back for this course later. And thanks for watching. See you in the next episode.